Good afternoon. I'm Mike Pfeiffer, and I'm going to spend the next half hour discussing galvanic corrosion. I recommend that if you may want to put the phone aside for the half hour. I'm going to be covering a lot of information, and if you just get distracted for a minute, you may miss something that will be important for the rest of the presentation. So today I'm going to talk about the corrosion cell, electrode potential, and galvanic series, three essential components of a galvanic cell, the factors that influence galvanic corrosion rate, and approaches to controlling galvanic corrosion. And at the end, if we have time, I'll have some questions for you, and then there'll be time for you to ask me questions. So first of all, I'm going to talk about corrosion. So corrosion involves chemical changes of a metal and its environment as electrical charges flow from the metal to the environment. And this is called an electrochemical reaction. During this reaction, the corroding metal atoms lose electrons, and the electrons go to the environment, and the metal atoms become a positively charged ion. The process for losing electrons, which is what happens with the metal atom, is called oxidation. So this is an oxidation reaction when an atom or molecule loses electrons. And gaining electrons is called reduction. That's a reduction process. So the environment atom there would be a reduction process going on there where there's gaining the electrons. With galvanic corrosion, we have dissimilar metals in contact in an electrolyte. An electrolyte is a conductive fluid. We have two different metals in contact. We have corrosion of what's called the more active metal, and I'll be explaining about that. So there's an active metal and a less active metal. The more active metal corrodes. The more active metal is also known as called the anode in the corrosion cell, and the less active metal is called the cathode. So oxidation occurs at the anode and reduction occurs at the cathode. This shows an electrochemical cell. In order for corrosion to occur, the four elements have to be present in the electrochemical cell. The first is an anode. This is the metal at which the corrosion occurs and the oxidation reactions occur, where the metal atoms lose electrons. And the general form of the reaction is shown here, where a metal atom loses electrons and the metal atom becomes an ion. The second part is the cathode. The cathode is where the reduction reactions occur. And that it can either occur on a separate piece of metal or on the same metal as the metal that's corroding. The third part is electrical contact between the anode and cathode. And this electrical contact allows electrons to flow from the anode to the cathode. And finally, there has to be an electrolyte, that is a conductive fluid that's in contact with both the anode and the cathode. If we eliminate any one of these parts of the cell, there will not be galvanic corrosion. No, excuse me, there will not be corrosion at all. In a corrosion cell, whether it's galvanic or otherwise, or any other corrosion mechanism, there's one thing that is held true, is that the number of electrons liberated at the anode equals the number of electrons that are consumed at the cathode. This has to be true in an electrochemical cell, which means then that the current at the anode is equal to the current at the cathode. So if we do things to a corrosion cell to cause the cathode reaction to speed up, then that will put a requirement on the anode to also speed up and produce more electrons. And if we do something to the cathode to make it slow down, the reaction slow down, then that will also allow the anode reaction to slow down. And that's because the number of electrons produced and the current has to be the same at the anode and cathode.